Hi everyone, in this video I'm going to take a look at the following problem. I want the general solution to the ordinary differential equation cos x dy dx plus 2y sine of x equals cos to the power 4 of x. Okay, so straight out of a textbook. I've not written the answer yet. Let's just jump in, see what we get. Okay, so the methods that we need to use for this one, well, what methods do we have available to us for first order ODEs? We have separation of variables. It's going to be pretty tough in this situation to collect things onto the right hand side and get all the x's and y's separated. That's going to be quite tough. And the other method is the integrating factors. I think that's a tick. I think we can use this method here. So the general form for integrating factors, dy dx plus p of xy equals q of x. You should know that off the top of your head if you're good at solving these problems. So what do we have? Are we close to this? No, because we don't have dy dx on its own. We have a cos in front of it, so we're going to have to divide that out. So our problem, what we're trying to solve, we need to divide through by cos x. So if we do that, we get dy dx plus 2y sine divided by cos. I'm just going to write that as tan. And one of those causes disappears. That's a little bit of good news. Still, we have a cube. Doesn't look particularly pretty at the moment. Okay, so the p of x, the number, or the function in front of y, is 2 tan of x, and the q of x, whatever's left over on the right hand side, is cos cubed. Not liking the look of this yet. Hopefully something nice is going to happen soon. So the integrating factor is e to the integral of p with respect to x. Okay, so if we put in our p, we integrate tan of x with respect to x. Okay, so I'm going to do a side note here, just going to think about this a bit more. Integrate tan. Well, tan by definition is sine divided by cos. So how do we integrate this one? Well, we should notice that we have a cos on the bottom, so a bit like a f of x, and almost its derivative on top. Almost. We're out by a negative sign. So what I'm going to do to fix that is put a negative sign there and a negative sign there. Now it's exact. So this is a standard rule for integration. If you have a fraction, there's a function on bottom and its derivative on top, then the integral is the log of the bottom. Okay, so if you integrate tan, the answer is minus log of cos, and I think we do a bit better than that. Let's put the negative in. Log of cos to the power minus 1, which is just 1 over cos. Okay, so that was a bit of work. This one's a little tough. Okay, so my integrating factor is e to the power of 2 log 1 over cos x. So the log of 1 over cos x is the integral of tan. And I've got this 2 here, so that needs to stay where it is. Okay, well, I would quite like to cancel off the e and the log. I can't quite do that yet because of the 2 in the way. But using the laws of logs, this 2 can come into here as a power. So we square 1 over cos, and then we can cancel off the e and the log. So this is 1 over cos squared x. Okay, so there you go. There's the integrating factor. Quite a bit of work in there for that. This is a tough question, separating some pretty good students with some excellent students, I'm guessing. So the next thing we need to do is multiply our equation in the general form by the integrating factor. So, oh, that was a bit messy. Let's do that again. So here's our equation in the general form. We want to times through by the integrating factor 1 over cos squared. So what are we going to have? Well, the left-hand side is always the same. It's just a product rule of the integrating factor and y. And the right-hand side simplifies quite nice, just down to cos. So let's write that. Let's do it on a clean page. So we have the left-hand side is the integrating factor times y. That's always true. It's ix times y. And the right-hand side is cos to the power 4 times by 1 over cos squared. Cos to the power 3 divided by cos squared, which is just cos. Okay, so all that work, we've got it down to this form, and we want to find this y here. So integrating both sides with respect to x, just to eliminate the dy dx here, we have 1 over cos squared x y is the integral of cos. Effectively just taking the d by dx to the other side to integrate. If we integrate cos, we have sine x plus c. Okay, now to get y on its own, times through by cos squared, we have cos squared x sine x plus c times cos squared x. And this is our solution. So there you go, another example, quite a tough one actually, of solving a differential equation using the integrating factor and quite a bit of knowledge of trigonometry and integration and a few other things along the way.